Hi guys, so today we're going to be talking about droughts, which is really the last section on the watersheds worksheet. I'm going to give you some more information about droughts, and that leads us into fire weather. So we're kind of combining those two into this one lecture. Sorry if this video is a little bit late. This is the second time I'm doing this video. Yesterday I did one, and I was all happy and realized I didn't share my screen, so I have to redo everything again today. So I'm going to start with the screen share, because this is really annoying not to share the screen. And I'm going to go ahead and close this. And I just want to go here to this lecture, the Fire Weather Climatology lecture, and I've got some stuff for you to do first. So I want you to be able to define those words on a document. That'll be part of what the lecture notes are that you're going to turn in. There are questions here that I want you to answer. Here's the text page that I'm going to be showing you some stuff at. And then there's a cool video here. And again, just your reaction to it. This is an amazing video of some guys escaping a forest fire. So please do this first, stop the video, and then come back, and you can get the rest. So the first thing we're going to do is we're going to go to the watersheds. Now, this is not the best way to do it. It kind of stinks because it's an audio, and I can't stop it from playing. There's no text version of this only. And so I'm going to have to skip through a couple things. But we'll start this way. This first paragraph here, this first page of the watersheds drought section is basically saying when I see things, does that mean that there's a drought? Like, how do I know if there's a drought? And the answer is many times it depends. Because dry grass just means it hasn't rained for a while. But in an area, that might be typical of what you would expect. In Chicago, maybe not so much. We usually get rain most of the year. But if I went to California and in the middle of the summer, I'm expecting dry conditions. I'm not expecting rain. So whatever was there should dry up. So it depends. And, you know, we'll kind of look through this kind of stuff. And I'm going to try to go forward through this as much as we can. Certainly, I want you to be able to do this. And go through here just to kind of get a really good feeling about this, okay? Then I'm going to continue on the next panel.
True or false?
And this statement here is absolutely true. And make sure you've got that written down. This is going to be a case. All areas can experience drought, and there's different dimensions of drought and different ideas. Okay, so again, in here, there's going to be some information. I'm going to skip forward to here and say, we're going to say there's 4 types of droughts. So if I ask you a question on a test, and I will, what are the 4 types of droughts? The first one is the meteorological drought, okay? And the meteorological drought is the one where there's a deficit of precipitation. And all these other things may be true, but a meteorological drought means it's raining less than normal. Now remember, normal is sort of a mean, a 30-year average. So this is a departure from normal, which we call an anomaly. And we've done these words before, so make sure you spell them right, okay? An anomaly is a deficit in precipitation. We're looking at negative anomalies. If it doesn't rain for some period of time, you might get grasses that are drying up. But eventually, you'll start to lower water levels, and then that's going to become what we call a hydrological drought. When the water tables start to come down. That could be rivers and lakes, it could be aquifers, it could be reservoirs behind a dam, where you start to lower the amount of water in there. Now, usually you're going to have a meteorological drought that leads to a hydrological drought. This is more significant. You could end the meteorological drought. You could get back to normal for the time being, maybe for the year. But the hydrological drought can last beyond that. So you can have a hydrological drought without a meteorological drought, and that's a possibility. The other kind of drought is agricultural drought, and that's when it stops raining or we can't create irrigation and water the crops. We start to get problems in the soil moisture, and that leads to problems with crops. All these things are part of that thing. So you can get an agricultural drought, which is really when it starts to impact a lot more. So these two are sort of offshoots of the meteorological drought. And then finally, we get what we call a socio-economic drought, where we start to impact communities, and we start to impact the economy. And the whole society changes because businesses go out of business. Restaurants may shut down. Nobody's got money if there's an agricultural rural area where nobody's spending money. So it impacts a whole area. The droughts of the 1930s, the Dust Bowl, and books like The Grapes of Wrath really talk about this socioeconomic change that comes about from a long-term drought. So there's more stuff on the hydrological drought.
Drought causes reduced flow.
So I'm going to go past this a little bit. Again, I apologize. This one's interesting. You can get flooding. Why is that? Well, when there's dry ground, the ground gets all parched and cracked. And a lot of times you get clay covering the ground. Remember that clay is a very small particle size, so water can't infiltrate into a parched ground. And believe it or not, that actually creates more runoff. So you need long rainfalls that fall gently. Heavy rains tend to run off too much in a parched, impermeable ground. So that's an
minimal
antecedent condition.
Human actions can intensify and even.
So here's some things in here you probably want to take a look at. Again, this is stuff that you should be doing, but I want you to have done that individually. These are the things I want you to know. Okay, impacts of droughts are going to give you a lot of stuff. And I gave you some questions on the worksheet about this one, environmental impacts. Ecosystems get changed. So here's that stuff. And then we have all sorts of things when we start to get to the economics, right? Dust in the air, dust storms, the Dust Bowl, right? Those are all things happening because of long-term drought. So let's skip through there, go to the next one.
True or false?
And this is an important one, right?
Precipitation event is enough to end a drought in most parts of the U.S.
And this is not going to be true, right? Now, it depends, is probably right, but most of the time you're not going to end a drought. Now, you may end a meteorological drought with a tropical storm. We're going to get into how we end droughts a little bit coming up.
Affecting watersheds in the dry region.
So here we are about ending a drought, and we're going to give some words about mitigation. And there's a lot of diagrams here, and I'm going to show you some current ones so that you get an idea of what we're talking about. So I'm going to skip through here.
You can access these.
You can look at this on your own, but I'm going to show you some things. And here's a word that you're going to need is amelioration. Okay, so termination or elimination and amelioration of a drought. Okay, so we're going to talk about that. And then here's the rest of the stuff. We're kind of good on these watershed ideas. I'm happy to end this one. Okay, so close that down, and I'm going to end this right here. And what I'm going to do is I'm going to go to our text page, which I gave you that link for. And over here it says fire and drought. So again, we're putting these two concepts together so that you understand how fire weather and drought conditions really go together. So we have a lot of these products here. Remember, we have a fire weather outlook for day 1 and 2, and then 3 to 8 is a longer outlook. Here's some red flag warnings going on across parts of the West today. Today's July 1st, when I made this video. And remember, this is the Storm Prediction Center, SPC, that puts out these fire weather outlooks. Now, I've asked you what are the types of drought. Now I want to say what are the 3 drought indices. Okay, so right over here, that's the word indices. And I realized this, and I thought everybody knew, but they don't, so I'm going to tell you. Indices is a word that's the plural of index. So if I ask you the index of something, the Palmer Drought Index, if I have more than one, those are indices. So I'm going to ask you, what are the 3 main ways of measuring a drought? What are the 3 indices? The first one is called the drought monitor. And I think I've asked you about this, to look at the current conditions for Illinois. And that might be different than the day that you're taking this module or whatever. So you can go to the site and see it for yourself. On this day, July 1st, we are looking at drought conditions across the United States according to the drought monitor. Now, there are 4 levels of drought, and you need to know this. There's moderate drought, severe drought, extreme drought, and then exceptional. So right now, we do not have exceptional drought anywhere in the United States, but we have a couple of regions here and here that are in extreme drought. Lots of severe drought, and then some moderate drought. The yellow is abnormally dry. That's not a drought condition. It's just saying we're a little bit drier than normal. Okay, that's the drought monitor. And on this page, you can also get a text version of this, of what are the impacts. About a year ago, I looked, and it was the lowest amount of drought in the United States on record. We've come back more into droughts. So remember, we expect there to be drought conditions. It's good that we have no exceptional drought right now. That may change, but we'll see how that works out. It changes all the time, and you can go back and see an animation of where the drought was. Look at this. This was last October of 2019, and we had a lot of drought in the southeast and across parts of Texas, and now you see all of that has been eliminated. There's no more drought left. Okay, I'm going to skip past this. Another drought index, the second one that you need to know, is called the Palmer Drought Index. So we have the drought monitor, and we have the Palmer Drought Index. Now the Palmer Drought Index, I'm not going to worry about this, but the green represents above normal conditions of moisture. So you can see at this time, a lot of the United States is wetter than normal. We came from a very wet spring and fall, so we've had good growing season. This is where your crops are. So it's normal or above normal for water. We're not worrying about drought stresses on plants and agricultural droughts. That's not necessarily true as we go over here to Nevada, up into Oregon, eastern Oregon, and then parts of Colorado and New Mexico. Even though it's very dry in Arizona, it's actually above normal, which is kind of crazy, right? It's a desert, but again, this is an anomaly. They also have what's known as the Palmer Drought Index, which is about the same thing. And all I want you to know is the Palmer Drought Index, the United States Drought Monitor. Those are two of the three. And they just go moderate, severe, and extreme. They don't have the exceptional. I'm going to ask you the four, so include exceptional, okay? Now, it says here, precipitation to ameliorate. So what this word amelioration is to make a bad thing better. So when we have a drought, that's a bad thing. So how much rain do we need in order to make it in 1 month not so bad? And there's a definition to go to only a moderate drought. And so parts of Arizona only need 1 to 2 inches. Nevada, 1 to 2 inches. Parts of New Mexico, 1 to 2 inches. Now the question is, how likely is that? See, there's a difference between what you need, which doesn't sound like a lot, but getting 1 to 2 inches in July in Nevada is just crazy. It's going to be hard to do. Florida needs maybe 4 to 6 inches, but that's more likely. They could get some big thunderstorms and ameliorate the drought. And we also have that in a 3-month period and 12-month period. And here's the precipitation needed to completely end a drought, to go back to completely normal conditions. So we have precipitation needed to make a bad drought better, amelioration, and then we have elimination, or totally getting rid of a drought, how much to end it. And so in Florida now we're looking at 12 to 15 inches will totally get rid of the drought. And that's the kind of thing. Well, what would do that in a month? Well, what if I had a hurricane? I could easily get 12 inches with a hurricane. So if a hurricane were to hit Florida or the Panhandle or parts of Texas, I could completely wipe out whatever the hydrological drought is. So this is all part of the Palmer. A little bit different than the drought monitor. They're just different ideas of what they put in to determining a drought. One of the things that you'll look at is the soil moisture. And notice I have the daily soil moisture. Here's how much water is in the soils. And then here is how does it vary from what's normal. So we're starting to see soil moisture drying things out west, but in the central US, it's more than normal. So you can't just look at the actual value. You want to look at how does that compare to the mean. We also have monthly values and monthly anomalies, and that's what we've got there. So soil moisture is a kind of a cool thing. Now the last of the indices is this thing called the Keach-Byram Drought Index. And the most important thing about the Keach-Byram Drought Index is that this is what's used for firefighting. So right now, it's as of June 30th, right? We see that it's not so bad. We get rid of the oranges and reds, maybe a little bit across southern Arizona, but it's really not that bad. And part of what they do is not just look at soil moisture and drought conditions, but also the effects on vegetation or dead vegetation. So you define some words. You define duff. That's the dead plant layer that covers floors of forest. In the spring, if you've ever walked through the Morton Arboretum or some forest, you know there's a lot of wet leaves. Those wet leaves are not going to burn. But if you let them go for a long time, they're going to start to dry out. And that's going to be true of dead trees, of branches, of twigs, maybe even dead trees that are still standing. You might start drying things out, okay? Now, the drying out of vegetation is called curing. And we do the same thing with meat. And I think you should have found that definition, curing the vegetation or the duff layer. The other word that was there was slash. So after you log an area in a forest, you have all sorts of wood chips that cover the ground. That's slash. So imagine that slash and duff are really dry and you've cleared out a forest. Something ignites that slash or duff, and now you have fuels that go quickly. Well, the fuels that go quickly are known as a 10-hour fuel moisture. So this really relates to how quickly things can burn, like grasses, very small diameter twigs. So what we're seeing is that it's fairly dry across the desert, which we would expect at the beginning of July. We're going to see that change in the future. Okay? Siri, don't talk to me. Over here, you do have all this dry, short-term grasses. So this is expected. It's not a drought. If you look over here, it's not a drought, but it's dry. And that's what you'd expect in the desert. Now, when you get to some larger twigs and branches and plants, now we have what's known as the 100-hour fuel moisture. And we start to see that this is not as bad as the 10-hour, which means it's going to take longer to cure the bigger things. If you've ever cut wood and you want to burn it, you know that if you cut wet wood, it's going to hard to burn. So you let it sit there for several months in a dry condition, and then you get that wood burning really easily. Well, that's the 100-hour. And then when I get into 1,000-hour, now you're talking about big branches, dead trees. And this shows you it's not as bad. The colors are closer to the yellows, which is in the middle range of this index. Okay, so the 1,000-hour moisture, this is a good one to write down, is a good indicator of long-term drought. And so we're not seeing a lot of long-term drought here. Maybe some shorter-term drought, as we see in the 10-hour supply, but not so much in the 1,000-hour supply. Okay? So we have all these things that go together, and these are all parts of this, how we measure how dry things are. So when I go back now to fire weather climatology, now we can put some understanding into this. So review drought severity. 4 levels would be moderate, severe, extreme, exceptional. You have 3 drought indices. You have the drought monitor, you have the Palmer drought index, and you have the Keach-Byram drought index. And then you have 4 types of droughts. Make sure you're clear on all of those things. So this one here, the source regions, and this is not my favorite module. I gave you a worksheet to help step you through it, and I'm going to give you some more now. So the first thing we're going to do is look at what does it mean for high pressure. Well, high pressure has sinking air, and obviously water vapor is coming from the ground. So if I'm bringing air from high up down, it's going to be drier. So these are source regions of air that's typically cooler and drier. And remember that air travels anticyclonically around areas of high pressure. So I'm concerned about this over here. So let me do this for a second. Ooh, I'll keep it there. What happens is if I've got continental polar air, what I tend to do is I bring that dry air southward into the United States. But it hits the mountains, and so it tends to go dry air down the front range of the Rocky Mountains. So in the central US, a big Canadian high tends to bring that dry air down. Now this one is a Pacific high. And the funny thing is, Pacific high, still anticyclonic, tends to be wet because it's maritime polar, and it tends to be wet along the west coast, the northwest coast. So you think of Seattle or Portland, Oregon being somewhat rainy. But then you go up these mountains. These are the Cascades and the Sierra Nevada mountains. And then when it comes over the mountains, it gets very dry. And I just happened to look back here. If you recall, notice it's very dry, not here where you've got flow coming on to Seattle, but on the other side of the mountains where this area is prolonged and dry. Okay, so that's what happens with the Pacific high. Now the Hudson Bay high has got flow over here, and you think, well, it's over Hudson Bay. That's going to be a polar, a maritime polar. But here's the thing. Hudson Bay is so far north, it remains frozen almost through May. And so this is all ice. And if this is all ice, then I'm not putting a lot of water vapor in the air. So this air tends to be really dry that comes out, and we start to bring dry air into the Great Lakes. And that's going to be especially true in March and April. In fact, a year ago, April, we had the driest relative humidity ever on record in Chicago. I think we went down to 11%. And that was in April, the driest relative humidity ever in Chicago. So that's April of 2019. Okay, so I hope that makes some sense here. Now in here, there's also just a little discussion here where they kind of give you some ideas in the maps. Don't worry about the maps. Grab some information from here, which is kind of what I wanted you to do. And then there's an exercise. So I want to make sure that you put this answers to this exercise in here, where you can go, put it in here, and once you're correct, it'll lock in there. And then just take a screen capture of the correct answers. And again, you could find the answers, but I'd like you to see if you can figure it out. That's a good way to learn. Okay, do it yourself. Don't wait for someone else to do it for you. Okay, let's go back to the main menu. And now we're going to go to lightning, and I'm going to do this kind of quick. Lightning, and here's some of the terms that we defined. The key term here is dry lightning. And dry lightning means it's raining, thunderstorms, with less than 1/10 of an inch of rain. Now, when you have less than 1/10 of an inch of rain, what happens is you tend not to wet the soil enough to really make it moist. Notice if you take just off of the covering of wet, it's very dry underneath it here. It's just kind of kicked it. That is also true under a canopy of leaves. If you've ever been out when it's raining, a lot of times you go under a tree because it's not raining on the ground under the tree. It's much lighter. So the canopy of leaves tends to stop the ground from getting wet. Once you get more than 1/10 of an inch, especially more than 2/10 of an inch, which is what we call wet lightning, then it's going to cover the ground, and that's usually enough to stop or to suppress fire starts. So you would not expect a lightning bust when there's wet lightning. You might get it in dry lightning, even wet dry lightning, which I'm not too worried about, because here's an example where I've got a cell and it might be raining pretty well in this cell. So we've got a lot of water coming down, and any lightning that hits in this sector, and I guess I could make my little lightning bolt black lightning here. Here's lightning hitting down. It's probably it might start a fire, but it's going to get put out pretty rapidly. But on the fringes or on the margins of these cells, or where there's drier cells, if lightning were to hit here, there's not enough rain to do this. So you can still get more than 1/10 of an inch of QPF, quantitative precipitation forecast. But because it's on the fringes or away from those, you can still trigger fires. It may not be a lightning bust, but you still can get some starts. Okay? Now in this, that is the definition of wet and dry lightning. Make sure you know lightning bust. Make sure you spell lightning. I'll fail you automatically if you don't spell lightning the correct way. I've had to unfriend people on Facebook because they put E's in here. And there is no E in the word lightning, so sorry, I have to do that. They do talk a little bit about this, and I think I asked you to do these questions. Super important that you do them. Ignition, here's a key thing, lightning ignition efficiency, which just says, hey, how well can lightning start fires? Fuel status, relative greenness, these are some of the maps that I talked to you about, the Keach Byram, how much we need, soil moisture anomalies, all these things. Here's 100-hour fuel moisture. I think my maps are nicer looking, so we'll have to just use that. And then there's an exercise that I want you to do. And all of these things you need to go through here, each one of them, and it's going to ask you which area do you think has the most lightning starts. Again, you could find the answer, but I want you to go through these, look at the map, and try to reason out, and just write a paragraph about what you would choose and why. Now, this is not easy. I don't expect that you're going to get it. If you get it, great, but there might be fire starts in a lot of places. Okay, so I'm not going to go anything to that. All I'm saying is that go figure it out and then look at the answer and include that answer there. We are going to talk about spread and how these things are. Now, a lot of this stuff should make sense. If temperatures go up, the relative humidity goes down. If it's raining, if there's winds condition, those are the red flag warnings, right? So what I want to do, though, is look at this mixing heights. And I'm going to draw a little picture of what happens when there's mixing. So the first thing I'm going to do is I'm going to draw the ground, okay, just so you know this is a cross section, and there's the ground. Now, when the sun comes out during the day, and here we are, there's the sun, and we're going to draw a little, there's the sun, rays of energy coming up. Now, the sun heats the earth through radiation, right? We know this. That's the best I can do with the wave, okay? And as it does that, what that's going to generate is motion in the low atmosphere. That's going to kind of look like this. I'm going to draw these two things. These are called eddies. And the eddies have motion on them, where on one side they may be rising, doesn't have to be a specific side, and then they're going to sink. So they're moving in kind of these big circles. And they're basically mixing up the atmosphere. So if you look at my picture, the air is kind of turbulent and mixing. You see gusts, you see birds soaring on these turbulent eddies, what pilots often call thermals. Okay, so that's mixing the atmosphere. And what happens is I mix the atmosphere, which usually has more moisture from the ground, and I bring moisture up. But what kind of air is normally up? And the answer, it's usually drier. So when I get this vertical mixing, because the sun comes out, I tend to bring dry air down. Now, it is not always. Sometimes I have more moisture above the surface and I bring that down. So it's not always, but mixing in the atmosphere in the late afternoon usually brings dry air down, usually. But here's the thing. The temperature here, and I'm going to use these colors, might be cool air. Okay? So I've got cool air up here, and what kind of air is going to be near the ground? The sun's come out, it's heating the air down here, so it's going to be warm air here. So what do you think is happening? Do you think that I'm going to mix cool air down? Is that what you think is going to happen? Most people would go, yes, that's what I think is going to happen. Reality is this air up here, even though it's cool, when I bring it down, gets compressed. Remember, air going up, pressure goes down, air coming down, pressure goes up. It gets compressed, gets more dense, and when it does that, it warms dry adiabatically, 10 degrees Celsius per kilometer. So this air comes down, and it's going to come down as warm. The air will actually get warmer with sinking air. That is, and what I'm going to say for this class, even though it's not technically always, for you guys in this class, mixing always brings warm air down. Okay, so super important that you keep that in mind, that mixing the air is bringing the warm air down. So what does that mean? It means, why is the temperature going up in the afternoon? Well, the sun's out, but that's only part of the reason. The other part is the sun generates eddies that bring warmer air down. It gets compressed and you get compressional warming and you get temperatures going up pretty rapidly. About at least a half, maybe more, of the temperature you see during the day going up is a result of mixing, not of the sun. It's actually a more important reason for temperature, a diurnal temperature swing. Speaking of diurnal, you guys remember that RH is equal to W over W sub S. The mixing ratio, the amount of vapor divided by the capacity. So what I'm looking at here is when I'm mixing, I'm bringing dry air down, which means the numerator gets smaller. The capacity, which depends on temperature, is going to get larger, which means the relative humidity goes down, and it goes down a lot. So, boys and girls, let's take a look at this. I'm going to show you something that I think is pretty interesting. I can get rid of my sun right now. And I'm going to show you an example of a high-resolution model in the southeast, and I'm going to look at relative humidity forecasts. And what I'm showing you is areas in the dark brown are less than 15%. That's red flag warnings. So look what we expect to happen as the day goes on. The very driest air is across the desert. In the peak of the afternoon sun, the warmest time of the day, that's when I've got the lowest relative humidity. The temperature goes up, the relative humidity goes down. Notice over here in southern Arizona, relative humidity is still at 39%. That is not going to be rapid fire, but this is where the fires are going to be the most. Winds are about 20 knots in places. Here they're 15 knots. So this area is going to be under the gun for later on, although parts of southern Arizona start to go, and then as we go into the night, the relative humidity comes back up and the fire threat goes down. So the fire spreading goes up and down based on the relative humidity, and that 15% out west is a super important delimiter. So I can look at dew points, but I got to know the temperature, so I use relative humidity for this, and that helps for fire weather. I can also look at wind gusts, and notice where is it going to be windy today. It's not ridiculously windy, much more windy down here where the relative humidities are not so bad. So today is not a day of big fire. Now, I want to show you something that I think is so cool. I'm using our satellite page, and I'm going to go to this region over here. And let me just set this up a little bit. I get this thing called natural color fire, and it actually sees where the air is hot. It's not seeing the fire visually, it's seeing the fires based on how hot those fires can be. So I want to go back in time on this. And I want you to see yesterday afternoon that we had some fires going on across parts of Arizona, New Mexico, and way up here in northern Arizona. This is showing you the smoke plumes of the fire. The satellite can see that. Now watch what happens as it goes into overnight. And you have to look closely. There's little red areas here and here. I'm not so much in New Mexico, which tells you these are really hot, big fires. So you can actually use satellite to measure that. We get up in the morning, guess what? I don't see the smoke. Why is that? Overnight, the fires were not so bad. We'll have to see if they re-intensify during the day as the relative humidities drop and the winds may pick up, may re-instigate that fire. If you're ever interested, you can do current wildfire in the US, and you can go to a kind of a fun page of active wildfires. I think this is the one I want. No, this isn't it. Let's look at this one. Nope. Something switched the other day. Active fire mapping, that's what I want. And they'll say, oh, look, there's one down in southern Arizona. That's a big one. It's got almost 115,000 acres. And then there's a little one that came up here. That's the one that started yesterday, 6,800 acres. They expect that it's going to be contained by July 10th. They don't know what caused it. I'm telling you right now, it couldn't have been lightning. So when we talk about fire starts, and this goes back to our fire weather climatology, some important things is that lightning, dry lightning, is a good starter. But you got to get thunderstorms to get dry lightning. So if it's not lightning starting fires, what else could it be? And the answer is we do. And the word that you should know is anthropogenic, which basically anthropology is the study of humans, and genic refers to Genesis, the beginning. So this is created by humans. Now, it's not necessarily arson, although that happens. People don't put out their campfires, or they burn a fire and it gets windy and ashes spread, and light fires and you get spotting going on. You also could get, and this is what happened in California a couple of years ago, you had fires being started by sparking from high tension electric power lines. So it's interesting that happened in California. My cousin actually lost his house, and it wasn't because it was a drought. People said, oh, it's climate change. No, actually it's the opposite. In January through April, there was a huge amounts of rain, and that rain caused all sorts of plants to grow. So we had huge amounts of plants growth in this wet winter. What happened as we moved into summer? Normally it just dries out. So we had a lot more vegetation, a lot more fuels to burn, and they didn't clear it out near the power lines. So when they started, they ignited in bad situations. Okay, so it's not always, easy to know what's going on. Fires happen quite a bit, and we always have to look at them. Okay, now I want to look over here at weather patterns conducive to lightning ignition. And I know that this is in your worksheet, so I'm going to go through a couple of things. The first one is the breakdown of the upper level ridge. Okay, where do I see that? Let me just go to this because I think this is easier. Okay, what does that mean? Well, let's go back to our whiteboard. And this time, and you're going to have to excuse me as I draw this. And right now we're going to start up here. Oh, here's Washington and Oregon. And then we go into Northern California, and then we get to the Bay. And then California kind of goes out this way, and we get Southern California. So it sort of looks like this. And it comes up this way. Oh, it's a little bit more straight over there. Oh, well. And then we go up here, Oregon, Washington, Puget Sound, something like this, okay? So over here is Nevada. We've got Vegas. We've got Arizona over here. We have the Four Corners region, something like that. So just get some idea of what's going on. Utah's up here and Idaho, blah. What I want to say is, well, what does this upper ridge mean? Well, I want you to imagine that I've got, and I'll make it a little bit larger. I'm getting my lawn cut. I hope it's not too distracting. Is I have a big upper level ridge. Now remember what a ridge is in the jet stream is where it's curving anticyclonically. Okay, so there's the curve anticyclonic, and that's a ridge. Now what does that mean? It means that the area underneath this ridge, in this area, is going to be, right here, hot and dry. So in this region, it's going to be hot and dry. And that's what a ridge does. So in a ridge, I'm not looking at extreme fire weather. Now, it could be dry, it could be sort of windy, but I have nothing naturally to start it. So I'm not looking at any lightning. I don't get thunderstorms under a ridge. But what that does is it sets up an antecedent condition where I have dry fuels that are curing. They're even getting drier. And so it's setting the stage, so to speak. Okay? Now, what does that mean? Well, if I have a ridge, what that's going to lend itself to do is I tend to get these little areas of a trough coming through. And anytime I have a trough, T-R-O-U-G-H, okay, a trough coming through, this area here is where I get storms. And so what you want to do is say the storms form downwind of an upper level trough. This is important. We're going to get this in the hurricanes. So here's the trough axis. Here's the downwind portion. So thunderstorms may go there. And what's going to happen is that these things are going to break into the ridge. So I'm going to get areas of maybe some scattered thunderstorms in this area as the ridge starts to get weakened break down. So you have long periods of hot, dry air that cure the fuels, and now you have mechanisms for thunderstorms to come in here. And that can set up fire weather conditions, okay? So that's what they mean by the breakdown of the upper level ridge. And you can go through here. Again, I'm not happy with this. I don't think it's a great scenario, a good module, but whatever. If I go to moisture surges, okay, and here they're going to talk about a couple things, and this is important, this diagram, is that there's two things to know. There's the pre-monsoonal moisture surge, and there's the high plains moisture surge. So I'm going to bring this back, get rid of this, and just bring my pen. So I get moisture. I'll use green for moisture. If I get big water vapor coming off the Gulf, and that's usually where it is, that's going to be maritime tropical air coming up to the front range of the Rockies. Anytime you see moisture returning, you start thinking in your mind thunderstorms. The other place is the monsoon. Now, in the monsoon, and this is a word that means season. So the wet season's coming up. I'll show you that in a second. But you tend to get water vapor coming in from down here off of either the Gulf of California or off of the Baja Peninsula in the Pacific. Warm waters here in the eastern Pacific. Not so much around California, but further south toward Mexico. This moisture surges back into the desert region, and that's a moisture surge. So when I take a look at something like this, I see that this is the season for the monsoon, or what we call the wet monsoon, which usually is in this time. So the critical period is pre-monsoon. Once I get to the monsoon, I get thunderstorms. A lot of times those thunderstorms produce a lot of rain, so they're not as prolific fire producers. But early in the season, maybe they've been dried out. We see the Keach Fire, I'm saying it's kind of dry in Arizona, and we see that. So we start to see that return of moisture. Now, how do I see a return of moisture? Well, what we do is we go back to our models, and I'm going to look at PWATS. That's the best way to see this thing coming, is precipitable water. So over here, I've got high precipitable water in yellow, and then purple is high, and then blue is pretty wet, and then green is less, and then brown is dry. So watch what happens in the south as time goes on. We start to see an increase in moisture, especially in the parts of Arizona. And that moisture is going to make the relative humidities not very favorable, although it can certainly bring thunderstorms to the area. So now look at this in Utah. If this is true, Utah sees a little bit of return of moisture, so I can look for thunderstorms in that area. And we're starting to get into a season where we'll see more and more thunderstorms out in the plains, or out in the desert region. Just to give you some idea of what thunderstorms might look like on a model, I might see a little bit of thunderstorms today. And again, not so much over the next couple of days, but scattered thunderstorms across parts of northern Arizona and parts of New Mexico. How much rain are they producing? This is a forecast radar, so this is what it should look like. How much rain am I getting at that time? You know, all the green, anything less than yellow is less than an inch. So some of the grays are less than 1/10 of an inch. So this is going to be wet, dry lightning. Some of these might be dry lightning. So you have to be careful of that. They could be a thunderstorm producing lightning, and those could do fire starts. Okay? So back to the fire weather climatology. I want to go back to the main menu because this is good. I'm not going to worry about hybrid. Really quickly, just post-frontal. The key thing about post-frontal is that we get a cold front go through, usually in spring, or maybe the fall. Here's one in April, here's one in October. And we get continental tropical air. So let's make that like nice and big in the back. If the front generates a lot of precipitation, well, then you're going to wet the ground, probably not going to get much to go in terms of fires. But if it comes in dry and you don't wet the ground, this air becomes dry. It also becomes windy. Now, it's behind the front, so there's no mechanism to generate thunderstorms. But again, any sort of brush fire can spread rapidly. So that's what a post-frontal situation is. The last one is the key one here that I want to talk about, and that is the downslope. And let's erase that. The downslope is winds that are over here that tend to come off of California. In Southern California, these are known as the Santa Ana winds. So there's a little article here about Santa Ana, and I'm just going to use this. Okay, so what happens, and this is usually September, October into November, and what happens is you get an area of high pressure building out here, okay? So you have a big area of high pressure. Let's go to blue. I like blue better. Okay, so we have big areas of high pressure. And again, keep in mind the cyclonic curvature around that, or anticyclonic curvature, excuse me. And then it comes, this is very dry. This is a big high desert. So the air comes around here, it's dry, and now it goes into like Death Valley. That's really dry. And then it comes over the mountains. So as it comes down over the mountains, it sinks further, compresses, and it warms up. Okay, and when it warms up even more, which is like what they're saying over here, you get adiabatic compression, warming, it gets very dry, and then it gets really windy. So it is not uncommon in parts of Southern California, and I'm hoping that some of you do a region of this, or a talk on this for your paper, is it's not unusual to get 5 to 10% relative humidity with winds that are 50 to 70 miles an hour. You can imagine a fire start there. Again, this is not going to be created by thunderstorms, but it will result in fires spreading really rapidly if they're anthropogenic. So those are the Santa Ana. And back on this region, this is kind of what we're talking about. So we care about the West Coast with downslope offshore winds. You can get winds coming over the Rockies from the west, and this is going to be the same thing on the front range of the Rockies. This is true also probably in fall, and you can get fires there. You can get the same thing in Alaska, big mountains to the south, and then you get hot, dry air up to the north. And we get a lot of fires that start there. You can do a fire weather for Alaska, and you'll see a lot of fires there. Okay, so all of those regions, downslope. The most important one of the Santa Anas, sometimes they're called the devil winds. And they just, again, they kind of talk to you about this. Here's the evolution. Those type of statements are pretty good in helping you understand that. And here's some of that wildfire that we talked about. And this is California getting a whole bunch of big fires. Okay, and this is what they may look like. So pretty amazing pictures. So go look at that movie in the Appalachians. I think that's pretty cool. So there's where we're expecting fire weather, and this is what happens, and this is what you can, if you're interested, you can monitor this. People use our page quite a bit to try to detect fires, to see this kind of thing. So we're kind of excited that this is all here. I'm going to go ahead and stop sharing, and I think that's what we're going to do with ending our module. So make sure you know those 4 patterns: the breakdown of the upper ridge, the the moisture searches, the pre-monsoonal is the big one. We also want you to do post-cold front, and then what's going on with the downslope winds. Okay, and I think there's an exercise in there you should take a look at. Okay, so that's fire weather and drought, and lots of information on this one, so really make it a good set of notes, and that will help you for test number 3. Okay, guys, hope you have a good day.